Hi everyone, my name is Yuchen Zhu, and this is my independent research project update. My project is about short-term traffic forecasting on the METR-LA dataset. Today I'm going to talk about my research question, the dataset I used, and the pre-processing steps, the baseline models I built, and the results I have so far. So, my main question is whether short-term traffic speed can be predicted accurately at 15 minutes, 30 minutes, and 60-minute horizons. Right now, my goal is not to jump straight into very advanced models. First, I wanted to build a clean pipeline and get some benchmark results using simple baseline models. That way, I can better understand how prediction error changes when the forecasting horizon gets longer. So for this project, I used the METRLA dataset. It has 34 to 72 time points, 207 traffic sensors, and the data were collected at 5-minute intervals. The first column is a timestamp, and the rest are traffic speed values from different sensors. So for pre-processing, I first fixed the timestamp format and sorted the data by time. When I handled missing values using interpolation and forward and backward filling, after that, I split the data into training, validation, and test sets, and standardized the value using only the training data. Um, on the right side, I included the first few rows of the clean data. So for the forecasting setup, I used the past 12 time steps as input, which means past 30 minutes of data. Then I predict the traffic speed 15, 30, and 60 minutes ahead. I implemented two baseline models. The first one is the persistence model, which simply uses the most recent value to predict the future. And the second one is linear regression, where I used the past 12 observation of uh, each sensor to predict future speed. I evaluated both models using MAE and RMSE. This is the simplest model in my project. The idea is very straightforward. It assumes the future value will be the same as the most recent observed value. Then, uh, even though it is simple, it gives me a useful benchmark. And in this plot, I show actual uh, versus predicted traffic speed for one sensor at the 15-minute horizon. I can see the model follows the general trend pretty well when traffic is stable. But when traffic changes suddenly, especially during sharp drops, the model reacts too slowly. It makes sense, but it is only copying the latest value. And the second model is linear regression. For this model, I fitted a separate regression model for each sensor. The inputs were the past 12 observations, and the target was future traffic speed at each horizon. In this plot, the linear regression model also follows the overall trend reasonably. Um, Compared with the persistence model, it is a little more flexible because it uses the whole recent history instead of only one point. but it still has trouble when the traffic speed changes very sharply. So it improves some parts, but it is still not enough for difficult cases. This slide shows the main result. The first thing we can see is that for both models, the error becomes larger when the forecasting horizon gets longer. So 15-minute prediction is easier, and 60-minute prediction is harder. The second thing is that the persistence model had lower MAE at all three horizons, while linear regression had lower RMSE at all three horizons. So overall, the two models each had some strengths. The persistence model stayed competitive, but linear regression helped reduce some larger errors. These results give me a useful baseline for future model comparison. And so far, one of the biggest problems was just getting the dataset into right format in R. I had to identify the timestamp column correctly, clean the field format, and then reorganized the data into sliding windows for forecasting. The part took more time than I expected. Another issue is that these simple models can capture short-term patterns, but they still do not handle sudden traffic changes very well. So my next step is to continue comparing these baseline models with stronger spatial temporal forecasting models and see whether more advanced models can better capture abrupt changes. On the last slide, I include the main references for the dataset and for advanced traffic forecasting methods. These papers are also important for the next stage of my project, but because they motivated the more advanced spatial temporal methods that I originally proposed. So to sum up, uh, at the stage I have finished the pre-processing pipeline and built two business models, which are persistence and linear regression. My current results show that longer horizon forecasting is more difficult, and that both baseline models can follow the general short-term trend, but still struggle with sudden changes. These results give me a starting point for the next part of the project. Yeah, that's all. Thank you.